Hey guys, welcome back to Distance Learning. Today we're going to go over week 7, day 2. Just like last time, I'm going to read you all the directions, then I'll read you the text, and then finally we'll come back at the end and answer the questions. Okay? Alright, let me go ahead and get my face off of here. Alright, day 2, first read and respond to text. Objective. Today we'll read pages 1 to 7 and answer questions about the text. Directions. Read pages 1 to 7 with minimal interruptions. Answer the questions below using complete sentences. Pay attention to grammar and punctuation. Be sure to use evidence from the text to support your answer. All this is telling us to do is to read the text and come back and answer the questions in complete sentences. Okay? So let's do just that. Alright. Science news for students. Animals. Electronics may confuse a bird's compass. Robins get disoriented when surrounded by the electromagnetic noise given off by some ordinary electronic devices. The magnetic sense of European robins, like the one shown here, may get confused by the electromagnetic radiation given off by electronic devices. H. Morrison. And what we're about to read right now is written by Stephen Orns, May 19, 2014 at 10:33 a.m. Birds know where to go when it's time to migrate. They get some of that superb sense of direction from their ability to detect Earth's magnetic field. That magnetic sense acts a bit like a compass used by human hikers, but the energy coming from some electronic devices can perturb a bird's internal compass, and that might confuse a bird's sense of direction, according to a new study. Most electronic devices send out waves of energy called electromagnetic radiation. The levels are too low to harm people. Any given device only sends out a small amount, but some types of this radiation could pose a problem to birds. Even when held captive in a lab, birds know when it's time to migrate. They fidget in their cages. They try to face in the direction they would fly away, if outdoors, but the birds can't always line up correctly, notes Henrik Mortensen. He's a biologist at the University of Oldenburg in Germany. He and his colleagues studied European robins, Ornithocus rubecula. They took some birds outside the city of Oldenburg to a rural area with low electromagnetic noise. There, the birds had no problem figuring out which way to turn, but birds caged in the city were confused. They were likely to face in the correct direction only when they were shielded from electromagnetic radiation. Morrison and his colleagues reported their findings May 7th in Nature. Electronic equipment can sometimes interfere with a magnetic compass. Scientists have long argued about whether such devices might also interfere with the biology of animals. That includes a bird's magnetic sense. Earlier studies have claimed to find such effects, but many scientists didn't accept those findings. Joseph Kirschvink has called for researchers to be more careful when studying the effects of electronic devices on birds' sense of direction. As a biomagnetist at the California Institute of Technology in Pasadena, he studied animals' magnetic sense. He says Morrison's team has done better work than any previous team in probing how electronic noise might affect birds' magnetic compass. As a result of this study, he told Science News, "I think it needs to be considered seriously." He also said he hopes to see other scientists try to confirm the new findings by running similar tests. Morrison's experiments began back in 2004. He observed that caged robins did not face toward their migratory directions. For several years, he could not figure out why. Then another researcher in his lab suggested that they set up a shield called a Faraday cage. It consisted of grounded aluminum screens that block incoming electromagnetic radiation. When protected by the screen, birds in the lab at last faced in the direction they should migrate. Over the next few years, Morrison and his colleagues kept testing the idea that electromagnetic noise upset a robin's sense of direction. They tried various ways to challenge it, yet their data always showed the same thing. The birds only faced the correct direction when the shield blocked out the electromagnetic radiation. Not all types of everyday radiation confuse the bird's sense of direction. Cell phones and power lines are often blamed for confusing birds, but the researchers reported that they had no effect in their tests. Morrison told Science News he was reluctant to start studying birds and electromagnetic radiation. After all, he knew that previous experiments that tested its effects on animals had been criticized as zany or sloppy. But he says he and his students worked hard to think of different ways to test their ideas. It's not the first time it's been claimed, he said, of the link between compass confusion and electronics. But I hope it's the first time it holds up. Excuse me. All right, guys. So now we are back at the questions. On the left side is going to be the chunk text. This is where they took a piece of the text and put it here. That way we can reread when we need to. In the middle column, it's going to be text-dependent questions. This is the question we're going to answer. And on the right side, we're going to write our evidence-based response. Okay? Question number 1. In what ways do electromagnetic noises affect birds? So I'm now going to read the chunk text so we can get our answer. Birds know where to go when it's time to migrate. They get some of that superb sense of direction from their ability to detect Earth's magnetic field. That magnetic sense acts a bit like a compass used by human hikers, but the energy coming from some electronic devices can perturb a bird's internal compass, in that, excuse me, might confuse a bird's sense of direction, according to a new study. Most electronic devices send out waves of energy called electromagnetic radiation. The levels are too low to harm people. Any given device only sends out a small amount, but some types of this radiation could pose a problem to birds. So again, guys, the question is, in what ways do electromagnetic noises affect birds? I'm going to have you about 10 seconds to go ahead and write your if that's not enough time, go ahead and pause the video and then continue it when you're done. Right, so we learned that electromagnetic noises affect birds' sense of direction and makes it hard for them to migrate because of that. Question number 2. Why aren't humans affected in the same way? Let's read the text to find out. Most electronic devices send out waves of energy called electromagnetic radiation. The levels are too low to harm people, and any given device only sends out a small amount. But some types of this radiation could pose a problem for birds. So again, the question is, why aren't humans affected in the same way? I'll give you 10 seconds to write your answer. So they don't harm humans because the levels of radiation are too low to harm people. Question number 3. How did Henrik Moritzen and his team prove that electromagnetic noise was affecting the migratory pattern of birds? Let's read that one more time. How did Henrik Moritzen and his team prove that electromagnetic noise was affecting the migratory pattern of birds? Let's read the text to find out. Moritzen's experiments began back in 2004. He observed that cage robins did not face toward their migratory directions. For several years, he could not figure out why. Then another researcher in his lab suggested that they set up a shield called a Faraday cage. It consisted of grounded aluminum screens that blocked incoming electromagnetic radiation. When protected by the screening, birds in the lab at last faced the direction they should migrate. So again, the question is, how did Henrik Moritzen and his team prove the electromagnetic noise was affecting the migratory pattern of birds? I'll give you 10 seconds. And again, if I'm moving too quickly, go ahead and pause the video, write your answer, then come back. So his team set up something called a Faraday cage, which blocked out the incoming radiation, and that cage allowed the birds to face the correct direction they would usually face when they migrate. This last question is very similar to this one we just answered. Let's go ahead and let's read it anyway, and then I'll tell you what I want you to do with it. Okay. Reread paragraphs 4, 9, and 10. In your words, describe the type of experiment used to determine that birds' navigation senses were perturbed from electromagnetic noise. So again, it's asking us this time to describe the experiment they used. It is the same one that we just talked about. It's called a Faraday cage. They just want you to put in your own words about how that experiment worked. Okay. After you do that, the lesson will be over. I'll give you 10 seconds to go ahead and do that really quickly, and then we'll come back. So again, you're just describing the experiment in your own words. Okay, guys, that's about it. Thank you for joining me. If you have any questions about the lesson or anything like that, please feel free to contact me. I look forward to seeing you guys soon. Stay safe.